Whoops. All right, a little shaky there. Sorry, a small earthquake when the recording started. But for those of you who are just joining on the recording, I accidentally went over this before. I identified that the coefficient of each of these terms here, coefficient of this term is -4, coefficient of this term is a 2, and the coefficient of this term is the understood 1 that's there. So it's just the numeric value that's in the front of the variable. And then if we put all these together, separated by pluses and minuses, then we call each of those values, these are the terms of this particular expression. So the first term would be -4x, the second term would be 2ln, the third term would be y, and the fourth term is -2. All right, thank you class for being patient while I blasted through that really quickly. What's more important, I think, that I want to talk about today, because that was just definition type stuff, is making sure that you guys understand the distributive property. All right, and so the distributive property, again, this should be something that you've seen before, but what the distributive property says is that if I have an expression like this, in order to solve this, I want to distribute this a through everything that's inside here, which means, and see, this is why we had to define terms, which means that we have to multiply the a times every term that's in here. All right, so the distributive property says that this right here is equal to a times b plus a times c. Right? And we could have any number of terms inside there. If we had a times b plus c plus d plus e, plus ... To distribute that a, you would multiply it by every single term and add those together. So ab plus ac plus ad plus ae plus ... Just keep going, however many terms are there. So that's how we use the distributive property. And so if we were to have a problem like this example here that says solve this problem using distribution, right? Normally, what would we do? Normally, using our order of operations, how would we solve this?
So, the parentheses.
We'd handle everything in the parentheses first, right? And we would say that 6 minus 2 is 4, 4 plus 5 is 9, 9 minus 7 is 2, and so 2 times 4 is 8. So we'd come up with that using our order of operations, right? But this problem explicitly says I want you to distribute first, all right? So using our rules for distribution, we're going to take this 4 and we're going to multiply it times every term in here and add those together. So 4 times 6 is 24. I'm going to write it out explicitly just so we're clear. So I'm doing 4 times 6, and then I'm doing plus 4 times -2, right? Plus 4 times +5 plus 4 times -7. All right, I'm just multiplying that 4 times every term that's in there. Now, normally you would skip this step here. I'm just writing it down explicitly this time so you're seeing what we're doing. So when we do the math for that, we get a 24 here. +4 times a -2 gives us a -8 there. 4 times 5 is 20. And then 4 times -7 is -28, right? So now we've got just plus and minus all through here. We can just do the addition and subtraction. 24 minus 8, that's 16. 16 plus 20, that's 36. And 36 minus 28 equals 8. So we got the exact same answer that we got up here. Distribution will give us the same answer that we get if we did the parentheses first. Any questions about distribution? Yes?
Why would we do that? Like, because it's longer? Why would we do that with them?
So we normally wouldn't. We would normally always combine this together. The next example we have is gonna have variables in it. So variables is where we're gonna have to distribute because we don't have any way to combine these together since there's variables inside there, okay? But that's a good question. Yeah, we would normally always do it this way. That would be the simplest route, all right? So let's look at that next one. The next one says ln times x plus y plus 2p. And so see, now we've got this scenario where you've got these values inside the parentheses. We would only try to do the parentheses first, but we can't combine any of these together, so the only option that we have would be to distribute this, all right? And so we're going to do just like we did before. We're going to say ln times x plus ln times y plus ln times 2p, right? Just multiply the ln times each term. Now what I like to do when I'm multiplying these variables together is I like to put my variables in alphabetical order and always move the coefficient to the front. So if there's a number in there like there is in this 2p here, it should always be at the front of the final term, all right? So ln times x is going to be ln x. Ln times y is going to be ln y. Just all multiplied together. And then we're going to move the 2 to the front here. Ln, sorry, I said n and wrote down p. 2 times ln p is what ln times 2p would be. Any questions about how we went from here to here or from here to here? Does that make sense to everybody? Yeah? Okay. One more quick one. Negative 4 times 3 minus x. I don't think this is exactly what the problem is in the book, but something like that. Again, I just don't want the negative signs to mess you up, so we're doing the same sort of thing here. This time I'm going to try skipping this middle step, just to see if we can go directly from here down to here, okay? So what's my first term going to be when I distribute here?
Negative 12.
Negative 12, right? Negative 4 times 3 is negative 12. Does everybody see that? Right? And then what's the next term going to be? Somebody else.
Minus x, or negative x.
What are we multiplying together?
4 times, negative 4 times x.
Negative 4 times negative x. Think of this as a negative x. So what's our answer going to be? Negative 4 times negative x is going to be?
Negative 4x.
No. It's a negative times a negative.
Oh, that's right.
Right? It's going to be a positive. So it's going to be positive 4x. Right? You guys see that?
How did you get the 4x exactly?
So here's what I did. I distributed. So I said this first term came from negative 4 times this positive 3 here. Right? And then the next term came from the negative 4 times the negative x. All right? When we multiply together negative 4 times negative x, we've got two negatives, which becomes a positive 4x. Okay, so that's what we're actually adding. Does that make sense?
I'm just trying to understand like how the 4 converted to the x, like how it even got there in the first place.
Because I multiplied these together. When you distribute, you take the 4 and you multiply it times the first term, and then you take the 4 and you multiply it times the second term.
So basically how much it's multiplied by that number, that's where
Mm-hmm. Yep, exactly. Makes sense? You're taking it and you're multiplying it by everything that's in parentheses, which is what we did in each of these cases. We did the ln times that, then we added to that the ln times that, and then we added to that the ln times that. Same thing we did here. Negative 4 times 3, and then we added to that the negative 4 times negative x. And since we've got a negative times a negative, it became a positive. All right. I was going to move on, but I think I need to do one more, just to be sure. All right, let's try one more example. And this example is here they write it in a different order, but the process is still the same. Even though the LP is at the end, we're still just multiplying the LP times every term that's in here. So we're doing the exact same thing we did before. So what's our first term going to be when we multiply through by the LP, when we distribute the LP?
MP times x.
LP times x, right? It's just LP times this term here. So LP x, good. What else? What's my second term?
MP times -3.
Say it again.
MP times -3.
MP times -3y, all right? Since there's no plus or minus sign in between the 3 and the y, we think of this as one term, okay? So we're multiplying the LP times the entire thing. LP times -3y. And when you multiply a positive LP times a -3y, you get a -3, and I'm going to put my variables in order, LPY. Does everybody see that? Where I got that was I took LP and I multiplied it times -3y. Is that clear to everybody? And all I did is I like to put my variables in alphabetical order so I can keep them straight, is I rearrange the variables. But I can rearrange them because effectively all of these values here, what are they to one another? Like, how do they relate to one another? If I see a 3 next to an M, next to a P, next to a Y, and I'll even put the negative in the front, how do all those relate to one another? How do I think about that mathematically?
Because they're all ones.
They're not all ones. These variables, these are variables that just kind of, they can contain any value that we decide that they're going to be. They could be equal to 1. But what am I thinking about this? Am I thinking about this as raising to a power, or adding, subtracting, multiplying, dividing? How do I think about all these terms in relation to one another? They're all what together? Anybody know? They're multiplied together, right? If you see two values right next to one another and there's no sign, there's nothing in between it that indicates they're added or subtracted or anything like that, no operator in between them, your assumption is they're all multiplied together, all right? And so since they're all multiplied together, I can write them down in any order, right? Because with multiplication, it doesn't matter if I say 2 times 3 or if I say 3 times 2, I get the same answer. And so that's why I'm rearranging my variables here. That's why I'm allowed to put them in alphabetical order, because they're just all multiplied together. And we can move stuff around when it's all multiplied together. Okay? Is that clear? And so what's my last term? Somebody else that's not on the board. Can you give me my last term? Putting it in alphabetical order? Yep.
X.
Say that again? X?
I don't know what you're asking.
I want to know, so here's the term, here's my two terms so far. So I've distributed my MP, I've multiplied it times that. I've distributed my MP and multiplied it times that. And now I want to distribute my MP and multiply it times this term here.
Z.
Did you say Z?
Is it?
It's all of that multiplied together. It's MP times XZ. So what is MP times XZ going to be when I multiply it together and put my variables in alphabetical order? Cooper?
Is it XMP2? I mean, Z?
Close. X comes after M and P in the alphabet, right? So it's just going to be exactly like it is here. It's just going to be plus M, P, X, Z, right? I put them all in alphabetical order, and that would be my final term. So let's move on to chapter 18 and let's talk about like terms. And it kind of goes along with what we have here. Like when you do this kind of distribution and all, you're kind of looking at the terms after you're done to see if you can combine any of them together. Yes? Yeah, go ahead. And you can only combine terms together if they have exactly the same variables, right? And that's why I like to put the variables in alphabetical order, because sometimes, you know, if you wrote this first term here, MXP, and maybe the second one was MPX, it might not be obvious to you that they're really like terms, but they are, because if we put them in alphabetical order, which we said we're allowed to do, they have the same variables in them, right? And so as long as you have like terms, I'll put a coefficient of 2 on the front of that, you can add or subtract those terms, right? And so 2 MPX minus, this is an understood 1 MPX, what would the value of that be? Does anybody know? You know how you figure out what the coefficient?
1 PX.
Huh?
1 MPX.
1 MPX, right? So you always subtract the coefficients. If the variables are the same in the terms, then you can subtract the coefficients. So 2 minus 1 is 1. And since we don't write the 1, since that's just understood, we would say that our final answer was MPX.
What if it was 2 MPX minus 1 PMY?
So then you couldn't do anything, you just have to leave it like it was, because they had different variables. They gotta have exactly the same.
As that,
That's right, that would be the answer. 2 mpx, and we wouldn't have the 1 there typically, but if say, like you said, mpy, that would be your answer. You couldn't go any further than that right there, okay? All right, good question. So like terms work that way, they have to have the exact same variables, and that's why it's so important that we recognize that we can move the variables around, because sometimes it's not obvious that they're the same until you put them in alphabetical order like I showed you, and then it becomes clear that, oh, these have exactly the same variables in it. So if you have, yes?
Can you ever like track the variables, so like you can like, if you have one on both sides, can you get rid of it? So that you don't have to write it down in your final answer?
So when you say on both sides, you're talking about we got an equal sign?
I meant like when you're subtracting.
So can you give me like a sample problem? Like what?
So just like what you have on the board already, could you get rid of M and P since you have it on
So
both
since
sides?
they're in both terms?
Yeah.
Oh, because it's over here?
No, before you get the answer.
Before that, okay, yeah, so right here, you can't do that, because what the rules of what algebra allows, let me say it like that, see, I got a smile out of you that time. What algebra allows is if we've got an equal sign in there, we can, whatever we do to one side of the equation, we can do to the right, or if we had just something all by itself, we could multiply the whole thing through by something that equates to 1, and that would be allowed. So for example, let's say I wanted to get rid of the M and the P here. I was going to say you could multiply through by this, and it would end up having the M and P on the bottom, but there's no way to do that. There's no way that you could remove those.
Could you put it over in P, so then you could like cross them out? Like,
So in order to do that, you're talking about something like that?
yeah, I was thinking like one under each one now.
Yeah, in order to do that, I would have to multiply the top and the bottom of this expression by MP over MP, because that's 1, right? MP over MP is 1, so I'm not changing the full value of the expression when I do that. But when I multiply through, now I'm actually going to have on the top, instead of just MP, I'm going to have 2 M squared P squared X minus M squared P squared X, all of that over MP. And I'm back in the same boat that I was. If I split them up like what you're talking about into terms like this and say MP down here minus M squared P squared X over MP here, then these MPs would cancel out with one of the MPs on the top. And once I simplify, I'm right back where I was before, 2MPX minus MPX. So yeah, there's no way to get rid of those, okay? So does everybody understand like terms? Like if I have 3x minus 4y plus 2x plus 3y, and I'm only allowed to combine like terms, which means terms that have the same variables, what would the final answer for this be? What terms would I be allowed to combine?
X and Y. Well, X and X and...
X and X and Y and Y, right. I knew what you were thinking, but we had to say it the right way. So all of my X terms I can combine, right? And all of my Y terms I can combine. So 3x plus 2x gives me what? 5x, right? 3 plus 2 is 5. Scare me there. All right, so 3 plus 2 is 5x. Remember, we only add the coefficients. And then negative 4 plus 3 is what?
Negative 1.
Negative 1, right? So we would say negative 1y, but we never write the 1. That's always understood. So we would just write that second term as negative y.
So
Okay.
basically, whatever the variable is set to that number is what you're supposed to do to basically, I don't know how to say this. I don't know the word for it. Oh, man.
Yeah?
So
Kirsten,
any
let's
number
see,
that
let's
has
like-
the same variable
Uh-huh.
is the ones you're gonna do the addition of or
That's right.
subtraction to.
Yep, for the coefficients of those variables, right? For the coefficients are the numbers in the front, all right? Kirsten, you have a comment?
Could you like keep the one in there, or do you have to take it out?
You could. I wouldn't count it wrong if you left the 1 in there, but I want you to get in the habit of removing that so that you understand if they were to give you a term like this, I want you to recognize that there's an understood 1 there, right? So yeah, I wouldn't count it wrong, but But teachers in the future might. So I do want you to understand that that's not necessary, and you wouldn't normally put that in. Okay? All right. Well, let's move on to that's really it for like terms. You can only combine the terms if they've got the same number of variables. That means if you have something like this, like right here, if I were to add a +3 onto the end of this, if that was what my expression was, there's no way I could simplify this any further, right? Because this term has an x variable in it and nothing else does. This term has a y variable in it and nothing else does. And this term has no variables in it, and there's not another term on here that has no variables in it, right? So I can't combine anything in this expression right here. All right, they have to have the same variables or they have to have no variables in order for you to be able to combine those terms together. Is that clear to everybody? All right, let's take a look at the next section, which has to do with exponents. And again, this stuff should be reviewed for you, but we're going over it again just in case it's not. Yes?
Can I use their short?
Yeah, sure. So if I have x to the 4th power, what does that mean exactly? What does that exponent mean? Yeah, Jonah?
Does it mean x times itself 4 times?
4 times, exactly, right? So that's what exponents mean. You're multiplying whatever this term is directly to the left of the exponent times itself that many times. So we have a 4 here, so it means we're multiplying x 4 times, right? And I'm sorry, I think I've kind of overlooked writing some people on the board, so you're going to have to press me and answer some stuff again, all right? Well, I'm sure that Cooper answered something, so I'm going to add you, Cooper. I don't remember what it was. There was something there, right? Okay, all right. So if we understand that, then that applies to, if I have 3 squared, that means 3 times 3 times itself twice, right? So that answer would be 9. And if I had -3 cubed, that would be what? Huh?
-3 times -3 times -3.
It wouldn't be. And the reason why is because the exponent only applies to what's directly to the left of it. Okay, so this would be, we would have a negative sign in the front here, but then over here we would have 3 times 3 times 3. All right, so we'd have to, and it turns out that the overall answer would be the same in this case because it's an odd numbered exponent. But 3 times 3 is 9, times 3 is 27, so our final answer here would be a -27. Where that really matters is like in a case like this, -3 squared, that is not -3 times -3, right? Which would give us a +9. It's not that. -3 squared equals a negative in the front, and then you have 3 times 3 here. And that equals a negative in the front times 9, which is just -9. Okay, so -3 squared, when it's written this way, would actually equal -9. In order for this to equal +9, you'd have to put parentheses around this, and that is when you could say that this is true, if you've got parentheses around. Okay, so the power only refers to what's directly to the left of it. And in this case, since what's directly to the left is the parentheses, then it's everything that's in the parentheses. Okay? Does that make sense? Yep. All right, so let's try another one just to make sure that we're getting it. So what if we had -3 to the 4th? What about that one? How would I think about that? Anybody want to take a stab? Again, I forgot to write. No, Ada, you're already down. Never mind. Cohen?
Wouldn't we just do negative, or put 2 negatives outside, and then put 3 threes?
So you're saying do this here, and then 3 times itself 4 times? Is that what you were saying?
Yes, sir.
Okay, not quite. Because remember, what does the 4 apply to? The 4 applies to everything that's, whatever's directly to the left of it. And what's directly to the left of it is the parentheses, right? So that means everything in the parentheses has got to be multiplied times itself 4 times. So really the way that we would do this is we would take this negative sign and we would put it in the front. And then we would say -3 times -3 times -3 times -3. All right? Do you guys see why it would be that? Then when we do the math on that, negative 3 times negative 3 is what? Yes?
Positive 9.
Positive 9. And positive 9 times negative 3 is, what's 9 times 3?
27.
27. So positive 9 times negative 3 would be negative 27. And then negative 27 times negative 3 would be a positive 81, I think. Positive 81. So I'm just going to do this in pieces real quick. So we'd have negative, we'd have a negative 3 times negative 3 would give us a positive 9, right? Yeah, it would definitely be 81, because we could multiply these in this order. And then we could combine these two together and say positive 9 times positive 9, right? Because that's what negative 3 times negative 3 is. And then finally we get a negative 81, which is just negative 81. All right, so you could do it in that order if you didn't want to have to do 3 times 27. Yes?
If there's 4 positives, wouldn't it be, or 4 negatives, wouldn't it be positive?
It would be, except we don't have 4 negatives, we have 5. So that negative comes into play at the very end. So you're right, this whole thing here will definitely become positive, right? Because we got 4 of them. But then you've got the negative on the front continuing. Okay? Make sense? All right, so let's do, let's put a few of these things into one problem and make sure we can get it right. Let's say we have, now this is combining several things together that we just learned. We're going to make sure that we've got it all figured out. We have to remember the exponent only applies to what's directly to the left of it. And so what's the right way to break this guy down and think about it? Yes?
With the negative 3, would it just be the 3? Because that's the only.
It would just apply to the 3, right? So we can't ignore this negative. This negative's in the front. But what we're multiplying together 3 times is just the 3. Right? It would look like that. And then for the second one, we'll maintain this negative here. But since we've got parentheses around this, then we would say it's negative 3 times negative 3. Right? We'll include the negative as we're multiplying them together. Does everybody get that? Because there's a parentheses directly to the left. And then here we'll keep this positive sign right here. And we'll say this is negative 2 times negative 2 because we've got parentheses. So negative 2 times negative 2. All right? So we could actually take a quick look at this, like, was it Kirsten? Kirsten, were you the one asking about the signs? On the last one where you said since there were 4 signs it would have to be positive? Who just asked me about that? Was it Alexa? Okay. Sorry, Kirsten. I hate to do this to you. So we can actually look at this. If we look at all of our signs, we will know what each of these terms, what the signs for each of these terms are going to end up being. What's the overall sign going to be for this term? Negative, because we've only got one negative sign. What's the overall term for this one going to be? No? It's going to be negative because we got 1, 2, 3 negative signs, right? We got an odd number of negative signs. And then for this last one, what's the overall sign going to be? That one's going to be positive, right? Because we got a negative and a negative, which gives us a positive, and then we got this other positive at the end. So the overall sign for this is going to be negative. 3 times 3 is 9 times 3 is 27. The overall sign for this one's also going to be negative because we got 3 negative signs. So we got 3 times 3, so it's going to be a negative 9. And then for this one, it's going to be positive because we got 2 negative signs multiplied together. And so our final answer is going to be positive 4. Is that clear to everybody? I don't want you to get mixed up on the signs. So I want to make sure that makes sense to you. And now we're just adding and subtracting in order. So negative 27 minus 9 is what?
36.
Negative 36. And then when we have negative 36 plus 4, we get what?
Negative 32.
Negative 32. There we go. Nice. All right. And you may be able to go directly from here to here, and that's fine. But if you're still your brain still doesn't quite do that quickly, then take the time to do this extra step, right? It'll just keep you from messing up a sign in there, losing a point on your answer because you did the math wrong. All right? Okay, let's talk about roots. And this is just when you're taking the square or the cube of something, right? When you've got something under a radical sign. So we're familiar with that already. You guys could probably already tell me what the square root of 9 is. Kirsten, you want to tell me what the square root of 9 is? Do you know what that is? Madeline, do you know?
It'd be 3.
Will, do you know? So Will's right. It would be 3 because this is like the reverse of what we just did with the powers, right? Yes.
Can I go to the version?
Yep, go for it.
Thank you.
So with the square root symbol, what's the understood? There's an understood number right here. What's the understood number when you just see a square root? Because I could say this. I could say the cube root of 9, which would be totally different. If you hear square, what do you think of? When we have square units, what's the little number at the end of the unit? 2, right? So there's an understood 2 here. We never write the 2, but if you just see that root symbol all by itself, you assume that it's a square root. And so what that means, what you're trying to figure out is what number can I square and get the number 9? So the number that I would square to get 9 would be the number 3. And so since 3 squared equals 9, then the square root of 9 equals 3. Okay? So it's the reverse of what we learned with the square. And same way if you have something like this, if you have the cube root of 8, what you're trying to figure out is what number can I raise to the 3rd power? Since it's a cube root, what number can I raise to the 3rd power and get 8? What would that answer be?
2.
It would be 2, right? So 2 raised to the 3rd power gives me 8. And since 2 raised to the 3rd power gives me 8, then the cube root of 8 equals 2. See how that works? Yes.
Can I go to the room?
Yes. So, again, you should have seen this before. This is definitely, at a minimum, this has been introduced in pre-algebra. But it may be something that you need to refamiliarize yourself with if you're still kind of confused about that. All right? Now, for right now, if I wanted the answer here to be, well, if I put a negative sign in front of this square root of 9, then I'm expecting the answer to be what?
A negative number?
So the final answer would be a negative number. So I'd say the negative of the square root of 9. The square root of 9 we said was 3 because 3 squared is 9, right?
Negative
So-
3 and positive 3?
So I would just say negative 3 in that case because of the negative in the front. The reason I say that is because some of you probably realize that what we're going to eventually learn is that if I have the square root of 9, I would say my answer was plus or minus 3. But right now at this point, they're not teaching us that. They're saying that if you see just square root of 9 all by itself, we're always going to assume that the answer is positive. Okay? And if they want you to give a negative answer, then they'll put a negative sign in the front there. Okay? Another way to think about this is that when you're taking the square root, we can realize that 9 can be split up into 3 times 3. And so anytime you're taking the square root of something, anything where you've got 2 of them in there, then you just get 1 when you take the square root of that. Yes?
So if you're doing like with the negative what's on top,
Uh-huh.
would you have to, would the exponent be negative?
So it would not. No. So this is not a negative exponent. This is just saying take the negative square root of 9. And since square root of 9 is 3, then it's the negative of 3, which is just negative 3. So think about it that way. Okay? Make sense? All right. Good question though. We are going to learn about negative exponents eventually, but we're not quite there yet. All right, so let's see if we can evaluate some problems now where they give us an equation and then they give us some values to plug into that equation. And we've got powers to contend with this time. So let's say we have y x squared m cubed, and they tell us to evaluate that when y equals 3, x equals 4, and m equals 2. So what are we going to do? How are we going to solve that problem?
You're gonna wanna convert all your variables into the numbers.
Yeah, I'm going to take my variables and I'm going to place the number in the place of the variable, right? So I'm going to substitute my numbers for that variable, okay? So if y equals 3, where I have the y here, I'm going to put a 3. Since x equals 4, where I have an x, I'm going to put a 4, and that 4 is squared. And then where I have an m, I'm going to put a 2, and that 2 is cubed, okay? Now in our order of operations, what comes first? Multiplication or raising to a power? Raising to a power. So I've got to contend with my powers first, right? So the 3 here stays the same. 4 squared is what? 16. Liam's my go-to calculator over here. And then what is 2 cubed? 2 times 2 times 2 is 8, right? So this is going to be 8. And then when I multiply all that out, I'm going to want to break up my calculator because I can't do all that in my head. I could go ahead and multiply the 3 times the 8, which gives me 24. But then when I got 24 times 16, I'm like, yeah, I'm going to use my calculator now. So the final answer here would be 384. All right? Is that clear to everybody? You guys see how you do that? Think you could do those on your own? I'm going to give you an opportunity to. Just because I love you so much, all right? You're going to get this, what my grandson says. I love you so much. It's not quite that clear since he's only 2. All right, last thing, which is going to be super easy because it's actually easier than the surface area thing that you've done. But it's a related concept. No questions about this? Everybody good? Everybody good on everything so far? You don't want to ask anything else? I'm going to slowly erase, move over. Glad we could share this moment together. Yeah? Okay, all right. So, what about volume when we talk about volume? So let's do the cylinder that we did earlier. Who asked about that? Who asked me to do a problem with that? So Allison asked me to do the surface area of a cylinder earlier, and we said it was 5 centimeters radius and 10 centimeters tall, right? And so our surface area, the rule for finding the surface area is take the area of the top plus the area of the bottom plus the area of the middle, right? Or area around it, depending on how you want to think about it. When we're doing volume, it's actually a lot easier. With volume, you only need it with volume for a right solid. And what did I say was a right solid? Do you guys remember how we defined any figure that's a right solid? The top and the bottom are the same, right? So this side as it comes down here is going to form a right angle with the bottoms. In other words, they're straight up and down. The sides are straight up and down. When you're finding the volume, all you have to do is take the area of the top or the bottom. Doesn't matter which one you pick, however you want to think about it, because they're the same. And you multiply that times the height. That's it, we're done, right? Super easy. So for this particular figure, the area of the top is a circle. So it's going to be pi r squared, right? Times our height, that is 10. And so we're going to plug in our 5. It's going to be pi times 5 squared times 10. 5 squared is 25. And 25 times 10 is 250, because the trick is if you have any number times a 1 with a 0 after it, then you just take however many zeros right here, you take that number of zeros and you slap it on the end of the number that it's multiplied by. So our answer would be 250. So this is going to be 250. I'm just going to leave the pi in there. You can punch that in your calculator and get a decimal if you wanted to. 250 pi, what would my units be in this case? Anybody know what volume units look like? Huh? They're cubed, right? So volume will always be cubed. So whatever our original units were, it'll be that unit cubed. Okay? And we can see that if we actually think about what we multiplied together. We multiplied a pi times the radius squared. Our radius was 5 centimeters squared times 10 centimeters, right? And so, it's supposed to be squared, sorry. So when we square that, we get pi times 25 squared is 25, but the centimeters has to also be squared. So 25 centimeters squared times the 10 centimeters. And when you multiply centimeters times centimeters, that's what actually gives us the 250 pi centimeters cubed. Centimeters squared times centimeters will give us centimeters cubed. Did we talk about that? Did I know that yet? Like, have we considered the fact that if I have x times x times x times x, I mean, this is kind of the reverse of what we said before when we were talking about powers. What's that going to be?
X squared 4.
No? Huh? Who said that? Oh, yes. So we have 4 x's, so it would just be x to the 4th, right? Because we said that's what that power means. It means that value multiplied times itself 4 times, right? So it's the same way with units. If we have centimeters squared, which means we have 2 centimeters, times another centimeter unit, that would be the same as centimeter times centimeter times centimeter. And so that unit's going to be centimeters cubed. Okay? So just think of your units as variables, and it'll always be sort of clear what your unit should be. All right, let's do one more example. We still have a few more minutes. And this particular problem says that we have a base that looks like this. The right angles for all these guys here. And they tell us that the base is 6, 4, and 10. So this is 6, this is 4, and this whole thing down here is 10. Okay? So this is our base. And they tell us that this base here creates a right prism, or they could say right a right solid. Anytime you see that word right in there, it means that we've got a scenario where the top and the bottom have the same shape, right? And so the sides are straight up and down. So it's a right prism that is 8 meters high. So this is the base here, and our height equals 8 meters. So all of these are in meters. And they ask us to find the volume. So the volume is super simple, because the volume is just the area of this time they call it the base. So it's the area of the base times the height. That's all we need. We just have to figure out the area of this figure, and then we're going to multiply it times the height that they gave us. Okay? So how would I figure out the area of this figure? Yep.
You would do 6 times 4.
Uh-huh. Okay.
And then you would subtract 4 from 10. So that would be 6, and then you multiply it by 6.
So what he's telling me here is that this value is 6, right? Because 4, so 10 minus 4 is going to give you 6, because this side here has a length of 4, right? So he's exactly right. That's all the values that we need to figure out the area of both of these figures. So if we call this area 1, right, the area of this rectangle here is just length times width. Yep.
How is the height 8, but the side of this square 6?
Because remember, the height is it's just like our they actually draw a picture in the book. Look on page 88, because I'll do a horrible job of it if I try to draw it. It's just like our cylinder, right? The height is just the length of the sides. So this is just the base. So imagine that as being the bottom of it, and then it stretches up top like this and has a top that looks the same way. Does that make sense? So this 8 here is totally independent of these numbers. Okay, it's just the length, the height of the actual object if we were to draw it in 3 dimensions. Okay? So if you're looking at your figure, if you're looking at that three-dimensional figure that they've drawn in the book, which is at the top there on the right side of page 88, the height would be this length over here, right? They've got a figure that's sort of, I'm going to just draw it. I'm sorry, guys. I'm going to apologize now. It's going to be so bad. See, that doesn't even look like my, at all. Let me draw this a little less. I'll try to draw that like that. And then we'll draw this down here like this. And then this is supposed to actually be more at an angle. So it looks kind of more like that, right? This shape here corresponds to that, but the 8 corresponds to that, okay? Thanks for making me look bad in front of the whole class by forcing me to draw that. Is that clear? All right, so we're just taking the area of this base here. So the area of this is going to be 6 times 4, right? Which is just going to be 24 meters squared. Our area is always in square units. And then this area here, area 2, is the area of a triangle. What's the formula for the area of a triangle?
1/2 times base times height.
1/2 base times height, right? 1/2 BH, or you could think of it as BH over 2. Either is fine. It's the same thing. The base for this one is 6, right? The height for this one is this distance here, so it's also 6. And then we divide that by 2, so we've got 36 divided by 2, which is 18. So this is going to be 18 meters squared. And so the area of our base altogether, if we calculate the area of our base, it's just going to be those two areas added together. So the area of the base is area 1 plus area 2, right? And then we're going to multiply that times the height to get our volume. So we have 24 meters squared. Why did I write 25? I don't know. 24 meters squared plus the area of the triangle, which is 18 meters squared. All of that times our 8 meters, which they gave us in the problem. So 24 plus 18, that's 32, 42 meters squared times 8 meters. And when we punch that in our calculator, we get 336. And remember, our final volume unit will always be cubic unit. So it'll be meters cubed, or cubic meters. Is that pretty simple? Isn't that easier than the surface area? Just take the area of the base and multiply it times the height they give you, right? Super simple. All right, any questions? Finished with like 30 seconds to spare.